B3D Webinar on the topic of 3D printing. I am Norbert Huller, who's hiding behind the slides. I'll quickly kick off the webinar and then turn it over to our hosts, Ilona and Anthony. We have a fairly full panel today. I'll just let you very quickly read over the list. A few people are going to be joining a little bit late. It is early Saturday in some parts of the world and very late Saturday over in Asia. So without further ado, let me turn it over to Ilona and Anthony, who have started up their own 3D printing operation. So hopefully we're going to get their perspective on what 3D printing is on the ground. Let me just switch this off and turn the camera over to, there we go. Over to you.
Okay. Go ahead, sorry.
Good morning, good afternoon. Anthony and I, we're both industrial designers. We have undergrad in industrial design and grad in interdisciplinary design. So that kind of brought us to the point that we realized that it's not just kind of design is not a discipline. It's a kind of an intersection of different disciplines. So I'm coming from the perspective of biology and design, and Anthony's coming from the perspective of digital additive manufacturing and industrial design. And the two of us kind of we participated in a biomimicry challenge a number of years ago, and we designed an ecosystem of manufacturing. So what we're really interested in is how can we redesign manufacturing so that it's viable for small-scale firms, so that it's scalable, it's sustainable, and can kind of exist within the economic realities of today and the future. And we ended up becoming the biomimicry finalists. So that kind of really inspired us to think that, oh, maybe we're not too crazy, and maybe we actually have a viable model. And so that brought us into ecotonus design and manufacturing. And the idea of ecotonus is kind of existing between biologically informed design and digital additive manufacturing. So how can we bring biological knowledge into design, and how can we translate that into the process of manufacturing, as well as how can we help manufacturing, the new types of manufacturing, inform kind of the future of biological research.
Okay. Said most of it.
Yeah.
So I don't know, do you want to bring up slides? Or?
Yeah, we can bring up slides.
All
right. I guess let's try this once. Can you see this?
Yeah.
Can you see the slides? Yeah. Okay. So this is the model, the ecosystem of manufacturing that we started with, and the idea is that we want to. We're not just interested in creating products. We're also interested in how to put these products within the bigger system of not just manufacturing, but also distribution, and kind of the slow evolution of products depending on what people want and need, and kind of help us adapt our products to like the changing realities. So in this system, it's a bit abstract, and we'll be able to show you some case studies later so that we can kind of ground this research. But the basics of it is that the kind of the circle that you see, it describes the cycle of the product. So starting from raw materials and ending with final disposition, which in fact kind of feeds back into the raw materials. And what you see on the right or left, depending on whether you see the mirror or the actual image, is that it's kind of the energy, thermal sources, electricity, material, knowledge, and just different types of I guess, virtual, non-physical entities that affect that process of design and manufacturing. And the reason why we wanted to do that is because we wanted to see how we can loop our system in between the physical and the
so the energy and the matter, how you can
Yeah.
try to close the loop more.
Yeah, that's a good way of putting it. And so out of that, Ecotona's Design and Manufacturing was born.
Okay. So initially for the biomimicry competition, we were just using moldless manufacture, and from that, along with my master's research, we've gone into digital additive manufacturing, which is additive manufacturing and 3D printing. So we're wanting to allow fewer material resources and lower energy intensity. Because if you like something like an injection molder requires vast amounts of energy to run, but it does things in a very short period of time, where renewable energies aren't necessarily that efficient. Where something like 3D printing, it takes a little bit longer to build a part, but you can solar power it. We're also, a key area we're looking into a lot is mesostructure design. So that is the sub-part features. We'll talk about that a little bit more.
Mm-hmm.
Also, I mentioned renewable energy. There's an idea of going down to like a square meter manufacturing. So you can have the equipment and the energy resources all within, ideally, something around a square meter, something that you could ship to places or go and print stuff out in a park, at a beach, whatever you like. And the other thing, which is a little bit further down the road, is hyperlocal biomaterials. So currently we use PLA, which is polylactic acid. It's bioplastic. It's fairly common with 3D printers. We've been doing a lot of engineering testing and everything with that. But the idea is to go towards a closed loop system where you compost the material and use it to grow a biomass that's high in starch, which you turn into more plastic and continue going on from there, which then anything reused can be recomposted again.
Mm-hmm. And so with that, actually, thank you very much for the questions and your comments, because that really helped us structure our presentation. So what we decided to do is just kind of go over some of the questions and kind of offer answers from our perspective, and really start a discussion on what you think the future of digital additive manufacturing and biomimetics is. So I guess we can start with the first one, and it's socio-political and education implementations of scaled-up 3D printing.
So the one thing to scale up, we've been building all of our own machines, which allows us to, first of all, customize it to allow it sort of like an evolution machine. Each machine will evolve to do different features. So you can have some for small, very quick, higher detailed machines, or larger scale with obviously less detail. And these machines, we can very easily build more of them to scale up. And what was it, like in a month, something like our Canada earrings, just with a single machine, we can produce over 600 of the 600 pairs. So it's already something that's a fairly decent scale for niche markets. Okay. You can go on about education, I guess.
Yeah. Well, education is an interesting one, because actually Anthony and I, we're participating in local education initiatives in Ottawa schools, and we bring our 3D printer and kind of biological inspiration. So, for example, one of the workshops that we're doing is we're creating a firefly that's that is, part of it are 3D printed, and part of it's the children, 3 and 4th grade students, they can kind of assemble the Firefly together, and it will teach them about the behavior of it. So depending on the types of emissions or light emissions that they have. And also in the same time, they will be able to see the 3D printer in action and kind of participate within the process. So I find that 3D printing and like biological knowledge, they really engage students, regardless of what grade they are. Another tool that we're using is microscope. So we're bringing microscopes into schools and kind of letting children play with it and letting them explore kind of the microstructures of the organisms.
Yeah, do we want to join?
Let me just expand on the question there. I think one of the ideas was, well, the perception in the media is that 3D printing is going to take over manufacturing. I think the idea of scaling was also, how will 3D printing scale as a way of providing product?
Okay, so in that, I don't believe that it will ever offset truly mass production, like injection molding. It will it won't fully offset it. We'll always have injection molding. If you have things like paper clips or plastic coat hangers, those will still be mass produced because it's something that isn't. You don't really need to have it customized or have. They're good. Oh, what's happening here? They're seeing.
Yeah.
This is something that we've done, but we should just go to camera.
Yeah. Okay.
Yeah. But have them up there for us.
Okay.
Because now I'm distracted. So printing, obviously, it began with manufacturing in custom medical devices like hearing aids. So those are they're one-offs. We're attempting to bring it into more medium-scale production. However, no matter how good we make these machines or how many of them you have, your mass manufacturer is still going to have a place. However, where it can start to offset based on cost is if you have distributed systems. Because if every city has a center where there's printers that can manufacture, then now you all of a sudden don't have the shipping costs. And with changing climates around the world, it can become more secure system of delivering goods. For instance, several years ago now, when there was a flood in can't remember if it's Thailand, but that's where all the manufacturing of motors for hard drives was done. And the world price skyrocketed because that's the only location. It wasn't a very stable ecosystem, if you will, where that's something that a distributed network can help. Can you hear? We didn't switch it to camera.
Okay, so let me switch that to camera then.
Everybody's seeing something I'm not talking about.
Okay. This one?
No, what are we doing? Go to
what?
Pull up the questions. We're talking about the questions. Does that answer that, or? So we're just having screen issues here. No, leave the camera on.
Okay.
You can just read. You can just read the questions.
Yeah, like they have the questions too.
Okay, good.
So this is you.
Okay. Okay, so the next question is, how can nature inform the entire manufacturing life cycle? And I think this one is kind of is very literal, actually, because we can, and I think since we're all very familiar with biomimicry, biomimetics, bionics, I think we all know that nature kind of took a lot of time to evolve into particular types of ecosystems, and I think that's kind of what we're doing as well. So we're not, we don't have answers right now because the ecosystem is only now starting. So we're at the starting point of kind of the development of that ecosystem. And what we'd like to do is kind of take the idea of ecosystem of manufacturing, the one that we showed you earlier, and continually adapt it. And we're already doing that. So for example, we have a solar panel that will hopefully be able to hook up to our printer and kind of add another layer of like sustainable energy production in order to run our printers. And as Anthony mentioned before, the idea of biomaterials and actually closing the loop of the production of biomaterials. So having our own vertical gardens to grow the material, and then to have our products compost and and kind of close the loop of material production. So PLA, for example, polylactic acids, it's completely biodegradable. Another important kind of topic that Ecotonus is addressing is the idea of highly accessible materials. So, for example, Anthony, like if you can show on the camera like this.
Okay, or just the. So one different thing is stuff like belts or aluminum extrusions are fairly hard to find in different locations, but stuff like angle iron or fishing line is, this is high tensile braided line, is highly accessible. So the equipment can be manufactured with stuff like this. We'll show you the printer after though, and some of those features. Existing manufacturing technologies. So that's one that we're not sure.
No, that's the idea of engineering testing.
Yeah. So in regards to the 3D printing components and systems designed with existing manufacturing technologies, how we're interpreting that question is the idea. So in order to exist with current manufacturing has to exist with design. So we're working on design guidelines in order to. Alona has been working on for biology to design. I've been working on design to 3D printing. So stuff like engineering tensile specimens with varied mesostructures, so the internal details are varied, in order to figure out what differences, what applies, and those can be informed by biology itself.
Well, and that actually feeds into the idea of mesostructures. Have you talked about that?
No. Okay. You can talk about it.
Okay. Well, so quite often we as industrial designers, we've been trained to design products on the macro scale. So quite like think of like toasters, chairs, tables. Like it's all about taking a material and then basically either applying subtractive or additive manufacturing techniques in order to like turn a hunk of wood into let's say a table. And what we think, what biological knowledge and finally digital additive manufacture, the kind of the advantage that it offers is that you can now manipulate your products not on the macro scale but on mesoscale. So we're not yet at the atomic level, but mesoscale is kind of this. It's the scale between the macro and the micro, which allows us through infill. So for example, again in the case of this, you can manipulate the infill of the product in order to kind of manipulate its mechanical properties. So for example, if you take a look at this object over here. It's by manipulating its internal structure, you can retain or even make superior its mechanical properties, and yet you're still very efficient on the material usage.
It's only 25% infill.
Yeah.
It's you can't really see it with that.
So depending on the percentage of the infill, you can actually it's almost like femur bone. So you can place your mesostructure in different parts of the product, and the product will behave differently depending on where that mesostructure is.
I guess we could talk about the guitar pick then. So one example of that is our guitar pick that we built. So initially, the process started off with just printing a guitar pick. This was the very first one, just how a 3D printer would normally print it, which it failed very promptly. And then through several dozen iterations, we've gotten to a form where its internal details is actually a honeycomb structure that is laminated at 50 micron widths to get a manufactured pick that you can strum a table with.
Okay, so then another interesting question actually was about bespoke versus mass market, and that's something that Anthony and I we discuss a lot because I also work at a company, at a commerce company, so it's kind of like my other job. And at e-commerce, or commerce is evolving into e-commerce, and it's interesting because it helped a lot of makers or bespoke, I guess, designers to be able to get into kind of a mass market and to actually produce their goods and sell them, and not have the initial capital investments of a large corporation. And the same thing is happening with manufacturing as well, because with 3D printing and digital additive manufacturing, you can now have makers who have developed products in their basement, and they can now bring it to the market. So we believe that there's no longer such thing as bespoke versus mass market. Bespoke is becoming mass market, and that's where 3D printing can really help.
It's because you don't have the initial investment costs of like injection molding. You have to have, it depends on where you are, but hundreds of thousands to millions of dollars to get an injection molding line running for little plastic components that you can, on a 3D printer, you don't need that initial investment. You either have to buy a printer and get expertise with it, or use services that offer them.
Yeah, I think that's it. These are kind of all the questions. So please, now we would be more than happy if you told us what you think the future of it is.
Discussions.
If you have any questions.
Juice?
Well, mass market, and then the bespoke bit, isn't it, is making the inner lining fitting your feet, or it could be changing the tread that something's, so there's parts that are mass marketed because they are generic, but then the specific bits for fitting your individual body or your needs, then that's the part that needs to, change. And it could be that there's a sock liner that changes for, with soaking out water, then it could be biodegradable, couldn't it? That kind of thing. That it's a marriage of two elements, isn't it?
So almost mass customization products.
Yeah.
Yeah, I suppose you can do that with cars as well. Car seats, steering wheels. You've got a generic car model that's built in a certain place, but then parts of it are tailored to the climate and the user and that kind of thing. So it's merging the two things together. I mean, I see 3D printing as well as, you go into shopping malls now, and that's just gallery space for the shops. You see things, and there's certain things, and you can go to another store and order them and then get them 3D printed or do it at home. That's kind of the future, isn't it?
Yeah.
Well, also, I just recently was in London, and I stumbled upon a 3D printing cafe, and it's a really nice business model because basically it's two guys who have Ultimakers and a coffee shop, and people are coming into the coffee shop and they're ordering coffee and they're getting their stuff printed. The problem with that actually is what kind of the conversation that I had with him is, he mentioned that people are coming in with the preconception that they just give you the CAD model and then you just 3D print it, and they leave with an object in the end. And what he was saying is that he's actually incurring a lot of losses because people are coming in with a poorly with a CAD that's poorly prepared for the 3D printing. So he has to modify the G code, he has to modify the model, and it takes him a while to actually kind of get from the idea to the production.
But that's self-done.
Yeah.
Did you manage to go to the when you're in the exploration architecture exhibition? Because all the tables were 3D printed out of potato starch, and they got a student from the Architectural Association to make all the using SKO software to strip away any of the unwanted material. They're great. So really strong tables, looked amazing because they were partly see-through.
Yeah.
And they could just be disposed of later, and there's no effect to the environment. Well, minimal compared to other tables.
Yeah, absolutely.
On that, like with shoes and stuff, there is stuff like this is your normal filament. This is PLA, well PLA PHP, but it's flexible but not very. This is your Ninja Flex, which you can like wrap around your finger. It's very rubbery. So this is stuff that people are looking at for shoes. It's something we'll probably get into a bit because there's a couple industrial designers in town that are interested in doing customized shoes.
Mm-hmm.
So you can do stuff where you like the liners are 3D printed for insoles for people that suffer from different foot ailments. And
in that regard too, we're often approached by design students who are looking to, so they have a great idea, they have like a final model that they have produced, but they're looking to manufacture it. So this kind of brings up a really interesting opportunity to develop networks within your cities. So you mentioned. You mentioned kind of the idea of customization. Well, it becomes a local customization. So you mentioned kind of like customizing to local climates and individual needs. And I think with such accessible technology, it really allows people with different knowledge and different kind of training to come together and create a product that's bigger than themselves. Yeah.
I think that's really useful, isn't it? It means you don't walk into everybody's home and everything's IKEA.
Yeah.
Which is actually what these are for. These go onto an
IKEA shelf.
Gruntal shelf.
Yep.
So built with IKEA. But along those lines, so then because there's different levels of customization. Currently, there's, if you will, your mass-produced objects like injection molded plastics they're the far end. They're one product for millions or billions of people. And then what is often seen as what 3D printing will allow is that every single individual will have their own product, but for everybody doesn't need an individual product. Instead of supplying everybody's needs with one product, there could be 3 products instead. Like for instance, if you want to hang your blow dryer from an IKEA shelf, you probably don't need a different hook than me, or than Alona rather. So there's different levels of customization. So you have stuff like your running shoes, which is specifically for you, and then you have other stuff which can be customized for either your climate. For instance, some of you probably don't have a foot of snow outside, so our shoes are designed a little bit differently for Canadian winters than if you don't get winter. So it's just more customization along those lines and making it more accessible to people.
Yeah, and I guess that's I noticed that there's a lot of interesting projects on 3D printing where people are printing art objects, and they're printing a lot of future blue sky type of products. And what Anthony and I are doing is we're printing everyday objects. So since we're both industrial designers and we're kind of driven by limitations, which is actually what nature is driven by as well, we believe that it's important to use the technology of 3D printing to solve our everyday problems and to rigidly define what the challenges are, as opposed to kind of thinking in the future and thinking what what it might be in 2075. Yeah.
So that goes into our process decision. So a lot of the artwork stuff is done with sintered material or cured. So you've got your photosensitive polymers, which is like your Form 1's machine, and 3DS's machines, where instead what we're focusing on is extrusion-based systems, so sort of like FDM, MakerBots, that kind of stuff, because the material you're using is actually you can get biologically sourced materials, which aren't toxic, and both they're PLA is even biocompatible. People use it for medical inserts, and it's also common materials. So in terms of working it into current manufacturing uses thermoplastics predominantly for plastic artifacts. So that's where choosing what technology you use is also part of it, because engineers, designers, if you're building plastic widgets or products, then they have experience with thermoplastics more so than with photocured resins or the mechanical properties of a laser sintered powder. However, those are things that are obviously getting more experience with. Anybody else? Or?
Yeah.
Yeah. So I have a couple thoughts here. It seems like a very interesting model, but 3D printing is not a single technology. It's sort of multiple technologies. And one of the things that it does is it changes your distribution model, particularly for materials, right? So if you thought a little bit more broadly about materials distribution, you might also think about things like consumables. So the refill in your ink, in your pen, could be another market. And the question there might be, can you come up with alternative materials that are more environmentally benign that somehow sort of plays into your story?
So in terms of for consumables themselves?
Right. So could you invent a bio-based ink that works in my pen so I can replace this toxic material with something that's less benign? I can actually evolve the product at a local level.
So you're talking about making the ink itself, or making the casing?
Well, no, I'm thinking about materials distribution. So I think there's an opportunity there in terms of alternative materials that are more bio-based. I mean, you have kind of a multi-part thing. So kind of being monofocused on 3D printing is blinding you to some other opportunities that I think would fit nicely with your story.
Yes.
Yeah, and this is why we're very weary of saying like we're a 3D printing company because we're not.
Yeah.
Like, and there's a reason why we based our company on the manufacturing ecosystem rather than 3D printing. And I find that I agree with you completely. That do you think that
Go on.
I agree that that in order to if you can continue reinventing the casing for a pen, but if the ink is toxic, it doesn't matter. And the same thing is you can keep it reinventing the case for an iPhone, but if the microchips that go into it destroy ecosystems halfway around the world, it doesn't matter if your case is made out of PLA. and we found that there's a lot of manufacturing companies out there who design who focus on things like that. So for example, they focus on biodegradable iPhone cases, or biodegradable products in general.
I guess from your distribution system, so how I see the pen issue. So you can have I don't have a pen with me right now, but you in terms of casing, you can have it so you have like a very nice high impact material, like a metal, which is you constantly reuse it, or you can have something like a biodegradable plastic. So once you're done with it, it goes back into the earth. So it's like these guitar picks are biodegradable. They're hollow, so they use minimal material. And then you can have it so it's a refillable pen.
Right.
You like deal with, you get your cereal in a box, or you go to the store and just refill your Tupperware with it. It's a common idea in design and distribution. So do you go to your Business Depot, like here at Staples, and you plug your pen into a machine and it fills it up with new ink, or do you buy the internal cartridges?
So do you create a system around your product, basically? And I think you should. I think every product should have a system around it. Well, and also at the same time, we can also completely reinvent the pen, and to kind of think about how people are starting to use pen, and I'm sure it would be quite different than how we use pens in the 20th century. Because right now, first of all, there is an idea of electronic tables where, tablets, where you can just, kind of scratch the surface away, and then it will save into your hard drive whatever information you put in. So, like, you can create a system around existing products, or you can completely reinvent the product to match the evolving system. But I think either one, you have to always think about the system.
Right. Yeah. But I think there's an opportunity here to consider that there's already a lot of pens out there. Yeah. So why reinvent the wheel? It's just another opportunity. And if you're sort of looking at your location as sort of more of a distribution hub for materials, and your delivery technology might involve 3D printers, vacuum formers, filling devices, kind of a variety of tools and technologies to serve the need for reuse, adaptation, as well as invention and so on. So, so to sort of expand your story a little bit, I think there's probably a lot of opportunity there.
Yeah, that's. I mean, the idea of digital additive manufacturing is it's just that. So it's an additive manufacturing technique that is using computers to kind of drive it. And Anthony and I, we often discuss how digital additive manufacturing is just one of the bricks in the, like, within the whole set of tools that manufacturing entails. And I mean, but we're both industrial designers, and we come from the knowledge of vast manufacturing techniques and how each manufacturing technique is adapted to one particular type of use or product. And yeah, so it's a matter of capability, and it's a matter of time and resources.
Right. But nature has a vocabulary, and you don't have to do everything at once. But if you sort of think of it in terms of, there's a lot of diversity out there that we could be emulating. It sort of gets your mind going in terms of other possibilities for adding value.
Each tool has its purpose.
Right.
Yep.
But there's a huge diversity of possibilities here.
Yeah.
And kind of developing that vocabulary is part of the development of the ecosystem, right?
Yeah, absolutely. Well, and I mean, it's interesting too, because you're talking about equipment in particular, but also design is a very intangible process too. So you can develop a vast vocabulary of equipment and tools, but if you only have one design process, then it's going to fail. So for every tool, you need to have a different design process, and that's why I think that's another kind of, maybe another auxiliary inspiration from nature is the idea of building blocks. And I think instead of kind of spreading yourself thin and thinking about creating a design process for every new tool that you add to your toolbox, instead perfect one design process for one tool and then start building off of that. So I think that's kind of that's probably the approach that we're taking, simply to not get overwhelmed from the realities of possibilities, because we're both a little bit ADD.
Another approach to that problem is collaboration.
Yeah.
So again, an ecosystem doesn't form in a vacuum. It's a lot of things going on at once. So events like this, I think, are great for getting these ideas out there and getting the juices flowing, so to speak.
Yeah.
Yeah.
So one question I have is if you take a step back and look at 3D printing, what aspect of it has had the greatest impact on how you do what it is you do?
So how we do industrial design, like product design, or?
And I didn't want to specifically look at design because it is an end-to-end kind of a thing. If you look at it from an end-to-end perspective, where did 3D design have the biggest impact, and how did that come about?
But the greatest impact on,
I guess the biggest impact on our process, like, is that, so how did 3D printing affect our design process, I guess? Yeah.
So one of the big things that it does is it allows iteration a whole lot quicker. So in in design, you always make often we call them crap ups. I don't have one, or yeah, I do. I have one over here. Well, part of one. So this is sort of a crap up. It's a blower, but it's made out of. There are printed components on here, but it's just paper. It's a section for the 3D printer itself, which then you iterate and build a steel version, but only parts of that, the end caps are printed. So what printing allows is your design time can be shrunk a whole lot, because usually what you do, like 3D printing itself came out of rapid prototyping, which rapid prototyping was a way for designers to test out their stuff before sending it off to injection molding. So it's because design is usually a fairly iterative process, where what it allows, if you're doing manufacturing and prototyping with the same system, is that you can actually do things like engineering testing, reliability testing on your rapid prototype, which took you maybe a couple of hours to build or a couple of minutes, depending on how the size of what you're doing and your machine capabilities, which then you directly start to manufacture. And it's not, this is the final product, this is an iteration which is being sold. The product can constantly evolve to meet customer demands, or just to meet changing resources, changing machine capabilities. I guess to go back to this, like with the picks, we initially launched them a year ago, and since then I have done a whole lot of research on how to design for the process better and how to design the equipment, and now the picks take 5 times less time to manufacture, which is something, it's just through iteration, just constantly try something new, sort of evolution of a product.
Well, and from the human perspective, so because ultimately we design for humans, so while we're reiterating the process of manufacturing, we also go out and we start testing the different prototypes. So for example, we have tens of different guitar picks out there, and people are testing them for us, and they're sending us their modifications back, which is actually really interesting. So people kind of file down the guitar pick depending on what they want. They also talk about thicknesses, and they talk about different instruments that they play, and all that information kind of feed back into our system, and we can modify it on the spot. So instead of having to, again, retool, redesign, instead we tweak the design.
It's towards bespoke, like mass customization.
Yeah, and I guess, as Anthony mentioned, from the biological perspective, in biology, we quite often talk about the process of selection, but actually nature, a much more prominent process is the process of elimination. And it's an incredibly inefficient process. And the reason why nature is capable of doing it because it has, billions of years. Whereas what 3D printing allows us is that fast process of elimination. So instead of having to kind of design on paper and just kind of like think, oh well, which concept makes the most sense, which concept should we select? Instead, we can test hundreds of them very quickly and eliminate the ones that don't work very quickly. Mm-hmm. So it's almost an accelerated process of evolution, which is really neat, and it's actually something that was not capable. We were not able to do with any other manufacturing process, such as like injection molding or vacuum forming.
Yeah, even vacuum forming, you have to create the tooling and then you vacuum form it. So it's still an entire day process. Where with digital additive manufacture 3D printing, you can do many iterations within a single day.
Well, if you think thermoforming, it's the same idea. It's you still have to create a jig to cut away material. So in here, you manipulate the CAD as well as the G code. So you still manipulate kind of in virtual environment before you create a physical prototype. So it's really, like, it has helped us a lot with our product creation and product evolution. Yeah.
And it allows as you can't remember, it allows more of a ecosystem because you do have consumers taking part, or like the people that are interested in the product, people they're part of the community, they can take part in the evolution of the product, in it coming to market.
Yeah, it's really neat because well, the next thing that we're planning on doing is my father owns a bar in Ottawa, and there is a lot of musicians and artists that sort of come by, and he created this. The bar has existed for 10 years, so there is a whole kind of set of communities that frequents the bar. And the next thing that we're planning on doing is creating music events where musicians get together and they play different genres of music, and they use our kind of products made for music, and you create an event and you create connections and communities around like a simple guitar pick. So it's a really neat thing to kind of observe. Yeah.
But also on like the bespoke side, it allows you to do. This is not something we're selling currently, but it allows you to do stuff like this. So this is a dog bone cookie cutter for like dog treats. And it has, you can't really see it on the camera, but it has the name of the dog inscribed in it. So this is something that you can design the actual device, like the physical, this is the cookie cutter, and then you can insert different names, which is something, like this is the area of mass customization that even MakerBot does on their website, is you have default designs, certain little part of it, you can add your name to it. Or your dog's name in this case, which is Rascal. But
yeah, so like, and it's really like, so I guess to wrap it up, a long-winded answer is that we have a very high-level model that we're striving towards, and as you mentioned, it's the idea of building an ecosystem and building communities and kind of expanding our vocabulary of equipment and design tools. And then we have these really low-level projects, so really low-level products that are available, that can exist on the market today, like right now, and it's a really interesting process of bridging that incredibly high-level future research with incredibly low-level kind of physical products, and I think that partly also is what makes our job very exciting, is this continuous balance between the blue sky research and the kind of what's possible today. Yeah.
Any other questions? Give some of the other panelists a chance to ask questions or make comments.
I'm just interested in more. Actually, I'm setting invites on LinkedIn. Lane and Anthony, because my university, we're looking at setting up a knowledge transfer partnership with industry to use our 3D printing. So it could be useful to get your opinion on things and take this a bit further, since you guys obviously passionate about it and know your stuff as well. It'd be great.
That'd be no problem.
Yeah, that's actually. I mean, we're always looking for partnerships like that because, I mean, I think both of these disciplines, like biology and manufacturing, and especially something like such something as 3D printing, that's incredibly accessible type of manufacturing. I think these two fields, they present amazing opportunities for education because students get incredibly excited when you blend these two, the kind of biology design and manufacturing together, and kids of any ages as well, and it makes it very accessible and very tangible. So yeah.
There's a good book here to read as well. I don't know, it's
Structures in Nature.
Structure for design.
Yeah. So this looks like it's into mesostructures.
Yeah, this was first published in 1978.
Yeah.
So that's going way back, way before most I've even thought of it or were born.
Yeah.
Well, but yeah, yeah.
Richard, could you put it up again? We didn't get a chance to read the title.
Sorry. It was published by MIT Press.
Great, thank you.
Yeah, and I think also kind of as a comment on that particular publication is that I think digital additive manufacture will also allow you to finally bridge this centuries-old debate of form follows function or function follows form. Because as designers, there's this designers, architects, engineers. There's always this debate of do we emulate the form or do we emulate the function or process? And in reality, you emulate all of these. And the beauty of it is that you're able to emulate natural processes through form that then informs the function of it.
But this is also where we're interested in, particularly digital forming technologies, particularly additive ones, is that you can more easily, like the link that we're using and researching more in between digital additive manufacture and biological inspiration is that like many like as your book shows, there's a lot of structures in biology that perform different functions, but they're all on the meso level. Whereas digital additive manufacture or 3D printing allows you to actually control the mesostructures very finely. Where is it? So this is a little side of this is actually a part we're designing for our next manufacturing equipment, but you have precise control over what direction the fibers go and how wide they are, how tall. I don't know how well you can actually see that because it's really tiny there. Can everybody see the sort of, sorry, focus is weird. Okay, I'll just show this one's a little bit better. All these fibers, you have control over how tall they are, how wide they are. You can control the positioning. So this was printed like that. You would also print them like this to change the structure. And you can change the pattern on the inside. For instance, hopefully you can see this on the camera. Like this is the center of the guitar pick. It's instead of a crosshatch pattern, it is a honeycomb pattern, which allows it to be a little stronger, flexing in this direction.
Well, and also in the terms of like the earring, where you can manipulate the direction of the extruder.
Yeah,
so of course, natural structures evolved to be manufactured in a very specific way, and whenever we sort of just blindly emulate the form of a natural structure, thinking that it will work exactly the same if just the form is exactly the same, that's not the case, and the process is a lot more interesting to manipulate because it actually helps emulate the function of the structure. Yeah.
That leads to one other question. I think there's been a sense in the media that 3D printing can let you do anything.
No.
But I often have this fear that we're putting, into the hands of people who have no design expertise, a tool that allows them to instantiate their ideas without having the knowledge of how to do good design.
Mm-hmm.
That is the case, and it's also in the media. There's the whole gun issue with 3D printing, which is actually something at Carleton University. One of the professors was talking with me about that. He was concerned because there's lots of 3D printers at the school. Is that can anybody just go and print a gun now? Where there's tons of metal lathes and mills and everything, which they'd more likely do that there. It wouldn't be allowed. It's in in Canada, manufacturing of a weapon is illegal and highly persecuted, and not something people should do. But it takes skill. Even on for instance, we're both professional designers and experts in this. These picks took months just to get one that didn't break when you go like this with your finger. To build truly functional devices, it takes a little more than just pressing a print button on a machine like a MakerBot or anything. Which is where there's the interesting idea of, do we need, because with 3D printers it's always seen we need better technology to make it so that they're strong enough, where what we were interested in looking at is it better technology that we need or better design? Which most of the situations where we ask that, it's just better design.
Well, I guess we can pull up.
We can show our printer.
Yeah, so this is our printer.
No, that's a live. It's a live feed. Here, I'll just grab the camera.
Okay.
So this is we brought the machine up here. Can't really see. So it's simple angle iron, welded together. You've got your extruder here. Or sorry, I can't really see what I'm. Okay, yeah, I can hold that. No, you're going too close. You need to see. Okay. So you've got your extruder, which is there. X-axis, Y-axis is the heated bed moving back and forth. You have all your control systems held together under here. Material spool, which is mimicking a sewing machine, because you just have a couple little points, where it contacts and goes into the extruder. And then like this axis is still belt driven, where what I was talking about before is, so this axis has been switched over to fishing line, which is, it actually produces a much better axis. It doesn't have as much vibration in function. But this isn't a very pretty machine. It's a machine built for manufacture.
Yeah, and the interesting part is that you often see very sexy looking, sleek MakerBots that are kind of adorning the shelves of of classrooms, and these materials, the products are better quality and lower micron than what MakerBot can ever produce. So it's kind of just this it's very important to separate the
technology and the design.
Well, technology and the design, but also the spectacle of technology versus the use of technology. Yeah.
Because this machine is designed, like as you saw, I got right underneath the axis. It's important to be able to tune it in order to get very good results. So that's something that, and it's also allows you to mess around with the machine more, because in order to truly understand the technology, you have to play around with it a bit. Where a lot of the consumer grade printers, or in particular, you don't want to with the professional, like the industrial printers, which cost $20,000 plus, is you can't get into it and pull components apart and look at how it's made, see how you can modify it in order to allow you to design better objects, which is something that you can do with open source equipment, stuff that you've built yourself.
Yeah, customizable equipment, I guess.
Yeah.
So that's an interesting point, that you're actually evolving the technology at the same time as you're evolving the design.
Yeah.
Yes. So, for instance, like, I keep bringing this up just because it's in my hand. This guitar pick, we didn't really want to make guitar pick. It was just how can we push the machine to make a very thin product that is still very strong. And the pick actually evolved the machine quite a bit because these picks are now done at 50 micron, but the original ones to get it working were at 10 micron. MakerBots, the majority of machines max bottom out at 100 to 200 micron. So that's 0.2 millimeters, 200 micron.
Yeah.
So it by trying to do evolve products, you're also evolving the machine. We had to change the had to rebuild parts of the Z-axis. The extruder had to be completely redone in order to allow this to happen. So you have both an evolution of your product and an evolution of your equipment, which is something we're interested in because then it's all through design, and we're trying to keep everything as accessible as possible, as easily done. For instance, like the belting. The other day I was printing out a run of stuff, and the y-axis. Is that feedback there?
Okay.
I don't think that was up. The y-axis belt actually blew apart. In order to get another belt in Ottawa in time, it was going to be a couple of days to get a new one. Where if you have, if you're designing it to use something like fishing line, you can go. We have a store cleaning tire. It's just automotive everything store. You can just go get a roll of fishing line, and this is something like 150 yards in meters, but this is enough to run your machine for quite a long time, and it's not going to snap. And it also allows you to scale up your machines by sourcing different components. Because if you're using something like belting, you're fairly limited. You can't get a multi-meter belt that easily. Where this you can build a machine that's a meter by a meter quite easily. So it's just about switching materials for what's locally available. Just like a lot of the time you see Bird's Nest and they're using random scraps of garbage bags or party string because it's something that's available and it provides what they need. Just what's local.
Yep.
All right, we're running pretty well out of time here. Any last-minute thoughts? Any last-minute questions?
Anybody here?
Nothing of no last minute? All righty. Thanks to Ilona and Anthony for their very interesting perspectives on 3D printing from a practical side rather than from what we often hear in the media. And also the panel for a lot of very good questions that led to some interesting discussions. So without further ado, I'd like to wish all of you the best wishes for the holidays, and then we'll pick up the webinar series in 2015.
Thank you very much.
Thank you.
Bye, everybody.
Bye-bye.
Yeah.